All right, guys, this video is going to show you the parts of a compressional or longitudinal wave. Now, remember that they're talking about the exact same thing. It just happens to have two names for this shape of wave. All right, first thing, compressional waves or longitudinal waves are shaped like slinkies or springs, just like you see on that diagram on your screen. The next thing is compressional and longitudinal waves are always going to be mechanical type waves. So if you see a wave that is shaped like a spring, you know that it is going to be a mechanical type wave, just like right here. All right. So the first part we're going to talk about of a compressional wave is the compressions. This is the areas where they are smushed closer together. So they are color-coded on your diagram, and on this diagram, I did mark all of them on that wave just so it was a little bit easier to see. Since there are only three parts of this wave, it's a little bit easier for me to mark all of them on the diagram. The next part of the wave is a rarefaction. This is where the wave is more spread out. So they are marked in green on your diagram, just like that is highlighted in green up there with the definition. All right. And lastly, the last part we need to talk about is the wavelength. This one's a little bit different than on a transverse wave, but they are extremely similar. The wavelength is the distance between the center of one compression or rarefaction to the next. So there are two places that we can measure it on this wave. You can measure it between two compressions or two rarefactions. Now, you could also measure it between these rarefactions, or those are compressions, I'm sorry. You could measure it between those compressions, or you could measure it between these rarefactions, just like it's got at the bottom. Any of them will work. I just simply have it labeled in two places since there are two ways we can measure it. Those are the parts of a compressional or longitudinal wave.